Hello, students. My name is Dr. Brad Pitcher, but you can just call me Brad. And I have my PhD in geology, and in particular, I study volcanoes. I'm a postdoctoral scholar at Vanderbilt University here in Nashville. And I hear that you have all been learning about my favorite thing in the entire world, and that is geology, specifically volcanoes. So, I got to see all of your wonderful questions, and there are a lot of good ones there. Some ones that made me think, some ones that made me laugh, and some that I'm really excited to share with you. So let's go ahead and get into those questions that you have. So first of all, oh well, there's a picture of me out in the field in Japan wearing my Vanderbilt shirt. So go Doors. So one of the first questions was, have you ever been inside a volcano? So I think, probably people were imagining this, standing near a lava lake, rappelling into the volcano. I have not done that. It would be super cool, and maybe someday. But I haven't done that. However, I have been inside something like this, and you're thinking, oh my God, what is that? That's a lava tube where hot lava is just pouring through like a subway tunnel. And you're probably wondering, Brad, how have you been in there? Well, I wasn't in there while there's lava flowing through because lava forms this tube and then the lava just keeps flowing. And eventually, when the volcano stops erupting, you end up with these beautiful open tubes called lava tubes or pyroducts that you can crawl through. So, unfortunately, I don't have a picture of myself in there, but I have been in this exact one in Hawaii. It's called the Thurston Lava Tube. So, I suppose I've been inside of a volcano. Another question was, have you ever touched lava? The answer, with my finger, no, that would be very painful. But I have actually poked at lava. So I actually, for a class in undergrad at Central Washington University, we went to Hawaii and I get to walk right up to an active lava flow and dip my rock hammer, this rock hammer right here. I dipped it into the hot lava, peeled away the crust, and was able to dip it inside of lava and watch the lava cool right in front of my eyes. And what was cool is this is the rock that formed. This is literally, it's a rock called basalt, and this is the lava that cooled into this rock around my rock hammer. And you can see, it's kind of blurry, but you can see that this is the shape of it draping around my rock hammer. Cool, huh? So it brings me to the next question, which is, what is your favorite rock and why? This is probably one of my favorite rocks, the one I just showed you, because I know the exact moment that it was created. I know exactly when it cooled into an actual rock. So that's definitely one of my favorites. But another one of my faves is this guy right here, which is actually, this is sandstone, a sedimentary rock, inside of basalt, an igneous rock. And this is from Mount Etna, which is Europe's largest and most active volcano. And so the fact that this came flying out of the volcano means that while magma was coming up through the volcano, it must have grabbed some sandstone that was under the volcano and grabbed a chunk of it and ripped it out. So this is a pretty cool rock. And in case you want to get really nerdy, that type of rock is called a xenolith, meaning a foreign rock inside of a salt. So there you go. Okay, so another question, which I thought was a really great question, is there a fourth kind of rock? So you probably learned we have igneous, sedimentary, and metamorphic rocks. Okay, so is there a fourth one? Well, the answer is kind of yes. So metamorphic rocks are ones, if you remember, where the minerals, due to heat and pressure, change in the solid state into other minerals. And the rock completely metamorphoses, changes into something different rock without becoming melted. Now, an igneous rock is when melted rock, magma or lava, cools into a rock. There's actually an in-between there called migmatite, and it looks kind of like this. I've seen it in the field, it's very beautiful. It's one where the rock never fully melted, but the rock didn't fully stay solid. So it's actually in between an igneous and a metamorphic rock. And depending on which geologist you talk to, someone like me, I say, oh, it's probably more like igneous because I'm an igneous guy. But then metamorphic people, they try to claim it. So it's definitely some beef in the geology world. All right, so how many volcanoes have I visited? A lot. My favorite thing in the world is visiting volcanoes. So I've been to several active volcanoes. I went to Kilauea in Hawaii. That's where I got to poke at lava. It's actually currently erupting right now. You can you can Google it and watch live webcam. I went to Mount Etna in Italy. This is a large volcano bomb when I went there. I went to Sakurajima volcano in Japan, which is currently erupting and erupts almost every day. You can see in this picture. I was just happily taking a selfie while the volcano is erupting behind me. I've been to Yellowstone, which, if you've been to Yellowstone National Park, you may not have known that it's a super volcano. So I went there and was monitoring the volcano, making sure that everything was safe. And I've also been to White Island in New Zealand. Here's some pictures here. This volcano actually 4 months after I was there exploded, and unfortunately it killed some tourists. So that's one reason why we need to be very careful about going to active volcanoes and to make sure we only go when it's safe and to really pay attention to what volcanologists say about the risks. So I've also been in other active volcanoes that have erupted in the last, 100 or even 1,000 years, but are not currently erupting. So like South Sister in Oregon, maybe you've been to Bend, Oregon. This volcano's right there. I snowboarded down Mount St. Helens, and as we all know, that's an important volcano. Been to Costa Rica. Here's Irazu and Turrialba. And then I've also been to countless other dormant volcanoes, ones that haven't erupted in thousand or several thousand years. So another kind of a funny question was, do volcanoes have siblings? Um, Oddly enough, yes. So here, this is the Three Sisters volcano in Oregon, near Bend. And in the foreground here, this is South Sister volcano, Middle Sister volcano, and North Sister. But the original names were Faith, Hope, and Charity. And so all three of these volcanoes sort of nested on top of one another, and so they called them the Three Sisters. So it's kind of cool. Um, but in addition, sometimes we like to call volcanoes that are similar, both in the way they look, the way they erupt, the kind of rocks that make them up, the composition of them. We sometimes call them sister volcanoes. Turns out Mount Rainier, I'm sure all of you out there in Washington have seen Mount Rainier. Mount Rainier has a sister volcano called Nevado del Ruiz in Colombia. They look very similar. They have the same chemistry, and they are covered with a lot of snow. And so when they erupt, they can create catastrophic mud flows. So for a long time, we've recognized them as being sister volcanoes. But what's scary and important to know about that is in 1985, Nevado del Ruiz volcano erupted, created large mud flows that killed tens of thousands of people. So it's very important that we understand what made that volcano erupt the way it did, because Mount Rainier has done the same thing in the past, but before any written record of humans living in that direct area have been. So you can see here, this is a tree stump that came out of one of these giant mud flows that came from Mount Rainier. And if you've ever been to Ording, Washington, the whole town is built on top of one of these old mud flows. So, it's important to know that if mud flows happened in the past, a lahar, that it could happen in the future. And so that's actually one reason why saying that volcanoes have siblings is a good way to study one volcano in order to better know the sister. All right, so another question is, what do I do in the field and what do I use in the field? So one of my favorite parts about geology is I get to go out in the field all the time, go collect rocks and that kind of stuff. And so what I'm doing is I'm studying big explosive eruptions. And so I go out to these deposits from past eruptions and I collect the pumice from them. So pumice is, oh, it's the same stuff that you might have used to scrub your foot, maybe during a pedicure or something like that. But pumice is what's erupted out in explosive eruptions. So I collect these little pumice bits, and then I also measure the thickness of the ash layers and try to figure out, is this ash layer over here the same as this ash layer over here? So that's kind of what I do in the field. You can see that sometimes I'm at big rocky outcrops, sometimes I'm over here. I have to like swim to an outcrop, which was pretty fun. And in terms of what I use in the so the most important thing is a rock hammer. This is what we use to hit the rocks and then break them open and put them into chunks that we can take home to the lab. Another important thing that I use is this scraping tool. If there's too much moss and other biology crap all over my rocks, then I scrape that off with this so I can expose the rocks underneath. Very important to have your handy notebook so you can take field notes. Sometimes they include lovely drawing, even though my handwriting is terrible. And then a couple other things: eye protection for when you're hitting the rock. And then some other things. We have this neat compass that helps us figure out which way the rocks are tilting into the earth. So we have a lot of stuff when we're out in the field to help us with our geologizing. One question was, is Mount Everest a volcano? Turns out, no. It's big. I mean, it's the highest altitude mountain on Earth, but it actually is not volcanic. It wasn't created by magma. It was created when the Indian plate came slamming into the Eurasian plate within the last 10 million years. So it came slamming in, and because they were both the same kind of rock and the continent, they pushed each other up and then created the Himalaya Mountains, including Mount Everest. And what's wild is Mount Everest, we think of it as being the tallest mountain on Earth. Turns out Mauna Kea, the volcano that is creating the big island of Hawaii, Mauna Kea is actually taller. It's a mile taller than Mount Everest. It's just that most of it is underwater. And then what's even more crazy, there's a volcano on Mars called Olympus Mons that is the size of Arizona in its aerial extent, but it has a height that would be 15 miles. Isn't that nuts? So yes, our little Pipsqueak Mountains have nothing on that. All right, can rocks appear in space, and does that make our planet a rock? Absolutely, rocks can be in space. We know there's huge rocks like asteroids and then meteorites if they come flying into Earth and meteors if they just fly past Earth. So we know that these are made up of rocks. When we find them, these are actually just leftover pieces of cooled molten material that slammed into each other and slowly built bigger and bigger rocks due to the force of gravity. All right, so there's definitely rocks out there. Does it make our planet a rock? Absolutely. Our planet is made up of all rock bits and everything that was created at the beginning of our solar system. And then certainly the outside layer of crust is what we would consider a rock. Now, of course, there's molten rock on the inside. There's, hot plasticky stuff in the mantle. There's literally liquid in the outer core. So yeah, I would say certainly rock. And what's cool, another cool fact about that, did you know that the moon is is a bunch of chunks of rock that came from the Earth after a giant meteorite hit the Earth? It was called Theia. It was massive. It was like the size of Mars, and it came, and then all the little bits like came together and then like formed into the moon. So that's pretty wild. I would say certainly the moon's a rock, and that's made up of tiny chunks of Earth rocks. Cool. How hot is lava? Get this question all the time. It's hot. Certainly don't want to touch it. Don't walk on it, that's for sure. So it turns out that actually lava can be between 700 to 1200 degrees Celsius. Now, we scientists, we always talk in Celsius, but I'm sure that doesn't mean much to you. So lava can be 1300 to 2200 degrees Fahrenheit. I mean, you typically you certainly don't want to touch a pan that's in the oven, and the oven's only 400 degrees Fahrenheit. We're talking 2200. Wild.